So the next thing I'm going to be looking at is kind of, well, I won't tell you where I'm heading, so you might not have an idea just yet, but there is a point to this. And we're going to be looking at things back from the definition again. In fact, let me make the diagram much bigger. So we know that if we have a circle, center origin, radius r, then by drawing a ray from the center at angle, some angle, it will hit some point P, which will have some x coordinate of P and y coordinate of P, correct?
Yep.
Now, if this angle was theta, what is the x coordinate of P?
So it's also it's cosine theta.
Well, it's not exactly cosine theta. So what's cosine theta equal to?
It should be xp over y.
Not over y, but over?
The radius.
Right, over r. In other words, the x coordinate of P would equal?
Cosine theta multiply r. The radius. Right.
Good. And what's the y coordinate of P?
So it's r sine theta.
Right. And so, you know, that's obviously using the fact that sine theta is defined by the y coordinate of P divided by r, and that just gives us those coordinates. Great. Now, you know, I'm going to just go ahead and change this to beta. Then what happens? Does anything change?
No, just change the value.
Right, everything's going to be the same. So, you know, as far as, you know, x coordinate of P goes, then I'm just going to go ahead and change these to beta, right?
Yep.
All right, you're happy with that?
Yes.
All right, so now I'm going to just go ahead, and it doesn't really matter where it is, but I'm just going to draw one, say, here. And I'm just going to draw another ray. And I'm going to, you know, have this meet at point Q. And I'm now going to define that this angle is alpha. Now, clearly in my example here, alpha is in which quadrant?
The second quadrant.
And beta is in?
And it's in the first quadrant.
Right. Now, it doesn't have to be. I've just decided to, you know, make it that way. But, you know, I have a lot of flexibility, and there's no restriction on where I can put alpha and beta. Okay?
Yeah.
All right. But the point is, alpha and beta, in my example, I don't want them to equal. Otherwise, you don't really, you know, get much point out of this. I'm going to make them different, but there's no restriction on what alpha and beta are. Now, can you tell me the x and y coordinates of Q?
So the x is minus or negative r cosine alpha.
Are you sure? So let me ask you, by definition, what is cosine theta?
Oh, so it's x over the radius.
Right. Cosine theta by definition is x over r, right?
Yeah.
So how are we going to use that to help us find the x coordinate of Q?
So do we need to just 180 degrees minus alpha?
No, we don't. I think you're kind of missing the point here. Cosine theta equals x over r by definition, right?
Yeah. And it should
And
be.
what x?
So the x is negative.
Yeah, but the x is the x coordinate, right?
Yeah.
So no one ever said x has to be positive. X is just the x coordinate, right?
Yeah.
So when it comes to Q, what's the value of theta?
What's the value of theta?
What angle do we put in for theta to get Q?
I think it's just, I think just 180 degrees minus alpha.
So I think you're stuck with the idea that theta is acute. Did we ever say theta was acute?
Sorry, what do you mean by cosine theta is acute?
So I think you're stuck with the idea that theta is acute. And I guess, and I think, you know, I've tried to kind of tell you at the start of the lesson that, you know, it's not about right angle triangles. It really isn't about right angle triangles. We're not in year 9 anymore. So if we just think about the definition, we said we draw a ray from the center, right?
Yeah.
Now, I've always drawn it into the first quadrant just because, you know, it's been convenient, but let's just deliberately change it. All right, so I'm going to draw at some angle theta, and I'm going to get P at some XY, right?
Yeah.
All right, so how do I work out, you know, what's the definition of cosine theta?
So it's the x coordinates over the radius.
Right, and is X positive or negative in this example here?
It's negative.
Right, which is, and radius is positive, which is why we say cosine theta is negative in the second quadrant, right? That's exactly why we say that, yes?
Yes.
So how do we work out the X coordinate of P here?
So we just use negative x over r, but the x value is just.
So my question is, what's the X coordinate of P? So let me ask you, is the X coordinate of P positive or negative?
It's negative.
Right. So cosine of theta is X over R, right?
Yeah.
So what's X?
So it's just x. Oh, it's r cosine theta.
Do we need a negative in front?
Yes.
So you're saying it's negative R cosine theta?
Oh, so we don't need to just add negative, right? Just.
That's I guess what I'm trying to drive at. Cosine theta by definition is X over R for any theta, right?
Yes.
So we don't care about this angle that you keep referring to. You keep talking about 180 minus theta, but we don't care about that.
Yeah.
By definition, cosine of theta is X over R for any theta.
Yes.
That leads us to our definition that cosine theta is negative in the second quadrant, but it also means that the X coordinate is just simply R cos theta. And, you know, for the second quadrant, if theta is in quadrant 2, then that means cos theta is negative, but that naturally also means because X equals R cos theta, because this is negative and this is positive, then that's naturally negative.
Yep.
And so we don't need to put in a negative in front of that. In fact, if you put a negative in front, you then make the answer wrong.
Yeah.
Does that make sense?
Yeah, that makes sense.
So as I keep stressing, and I think you need to get comfortable with this, I think you're still kind of, you know, you've been impressioned so much with right angle triangles from year 9 and sort of maybe year 10 as well, that you keep thinking about in terms of the acute theta. That is maybe the way you've thought about it to start with in year 9. But when I first covered the circular sort of idea with you, I said, year 9 is year 9. This is the real definition, and that you've been looking at a sort of narrow slice of the real definition.
Yeah.
So yes, our theta is bigger than 90. No, we don't need to use the acute angle. We could, but there's no point here. And just directly, by definition, right from the first page, nothing to do with acute angles or anything like that, acute triangles. Sine of theta is always y over r, cosine theta is always x over r for any theta. So if we're talking about the x coordinate, it's just r cos theta for any theta.
Yeah.
So then bringing us back to this page then, what is the x coordinate of Q?
So it's just R cosine theta.
Well, what would be the right angle for Q?
Alpha.
Yeah, exactly. So it's always R cosine theta, but we just need to put in the right angle. In this case, it would just be alpha. And what's the y coordinate of Q?
So it's R sine alpha.
Right. Exactly. So similarly, using the definition. And so now at this point, we now have, oops. We now have the x coordinates of P and Q worked out in terms of alpha and beta, correct?
Yeah.
Happy with that?
Yes.
Good. All right. Now, I can join up the line PQ, right?
Yeah.
So my question is, I want you to calculate in terms of alpha and beta, the distance, the length of PQ. So that's my question here. So I've given you what P is. I've given you what Q is. They're these points on the circle, subtended by an angle alpha to the horizontal in the positive direction and beta. Now, how would you find the length of PQ? How do you plan to do that?
Maybe just using the sine rule.
You want to use the sine rule. How do you plan to use the sine rule here?
So, do we know the value for the radius?
You don't know, but I'm happy for you to, in terms of alpha and beta, that's not a problem. I'm asking you not to come up with a number, but an expression. So yes, it will depend on R as well.
So do we actually know the angle of alpha and beta?
No, you don't know the actual, you don't know the number for R, you don't know the number for alpha or beta, you don't know any of them. However, I'm asking you to not come up with a number, I'm asking you to come up with an expression. So your final answer will have R and alpha and beta in it. That's not a problem.
I think the cosine rule is work here.
Right. So not the sine rule. The sine rule will kind of be very messy. I can't say you definitely can't do it, but the cosine rule will definitely be a much better option. So the cosine rule, how are you going to apply the cosine rule here, to be clear?
So it's PQ squared.
In triangle PQO, yeah?
Oh, yeah.
All right, so I think you see it. Now, that means you're going to basically have PQ.
Yeah.
And you've got O, and you've got this, and you're trying to apply the cosine rule here. All right, so how do you apply the cosine rule? What do we know about this triangle?
So we know the value for PO and PQ, OQ, and the angle O.
So what's PO and QO?
So it's just the R.
Right, and what's angle POQ?
It's alpha minus beta.
Right. And you're saying use the cosine rule. So can you do that quickly and tell me what you get?
Yes.
All right, good. So you got the same thing. Now, you know, we won't bother square rooting it. We'll just leave it as PQ squared, all right?
Yep.
So we've got 2r squared, 1 minus cos alpha minus beta. All right, good. Can you do it another way?
So maybe we can just divide it into 2 parts.
What do you mean?
Like just calculate the right part and then add the left part of PQ.
But how do you plan to work out the right part? How do you plan to work out the right part? Or the left part? Like, how do you plan to do that?
Maybe just, oh, I think it's not working.
Well, I mean, you could do it. I just don't see, I'm not sure where you're heading with that. It's not impossible, but I just don't see why that would be a good method. And the work you would need to do for that one, yeah, there are easier ways, basically.
Yeah.
Because you'd have to work out the point of like the y-intercept first, right? And by the time you work out the y-intercept, you would have already finished the question, doing it some other way.
Yeah, I don't really know the second method.
You want to use this as a hint?
Oh.
We haven't used this yet, have we?
We haven't used it. Actually, I have used this kind of rules in the physics.
Oh, no. What I'm talking more about is we haven't used these to work out the answer yet, have we?
Oh, yeah.
Is there a way we could use these?
I think so.
How?
I don't really know.
No problem. Yeah?
Yes.
Any ideas how we might find PQ?
So we can just use the methods to calculate the distance, right?
So basically use the distance formula. What is the distance formula?
It should be r cosine beta minus r cosine alpha plus the y value minus, yeah.
Right. Could you quickly work that out? See what you get?
Yeah.
So we sub in the values for the x and y coordinates of P and Q, and then we work through the algebra.
Yeah. And
So that's what you've got at the moment, which I'll rewrite in a second. But you've got r squared times 2 cos squared beta plus cos squared alpha plus sine squared beta plus sine squared alpha minus, 2r cos beta cos alpha plus sine beta sine alpha. So I want to ask, can you simplify this part at all?
So yeah, so maybe just cosine square. No, I'm not really sure.
All right. So I'll write it out, and and then you'll hopefully, while you think about it, and see, focus on that part. See if you can sort of, see if you can figure out what you might be able to do about it. So if you expand this, you're going to get r squared cos squared alpha minus 2r squared cos alpha cos beta plus r squared cos squared beta. And you're also going to get r squared sine squared alpha minus 2r squared sine alpha sine beta plus r squared sine squared beta. Now, my question was, we could obviously factor stuff out, and we will, and let's just ignore the r squared because we can easily factor out the r squared, but you just take a look at the maybe this part, right? Can you do anything with this?
Oh, so it should be 1.
Can you do anything with this?
It should be 1 as well.
Right. So basically, we'll factor out r squared, right?
Yeah.
And once we have factor out r squared, then this becomes 1 minus 2 cos alpha cos beta. In other words, it's going to be r squared 2 minus 2 cos alpha cos beta. And I'll deliberately take out the negative 2, so this will become plus sine alpha sine beta. In other words, I'm going to have 2r squared 1 minus cos alpha cos beta plus sine alpha sine beta. Does that make sense?
Yeah.
Happy with everything?
Yes. All good.
All right. So that means we've got this answer for cosine rule, right?
Yeah.
And I've got this answer for distance formula.
Yeah.
And they're both PQ squared, aren't they?
Yeah, that's right.
Well then, compare the two. What conclusion can you draw?
So, so it's nearly the same thing, but maybe alpha equal to cosine alpha cosine beta. Is that?
So are these the same thing?
Yes.
So these must be the same, right? So how are they different? And how can they be the same? What's the conclusion you can draw?
So
We've got the 2r squared. We've got the 2r squared. We've got the bracket. We've got the bracket. We've got 1 minus. We've got 1 minus. So what can you tell me about this and this?
so it's equal.
Exactly. So we have now proven cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta for any alpha and beta.
Yeah. That makes sense.
Yeah. Good.